So here we have substeps and time scale. It will increase particle movement overall. So if you reduce this, it will slow down particles. And let me just disable this collision. Yeah. And if I increase this by 10, it will move faster. In a small scale, if you're simulating and you need faster movement, so you can use this. And next is minimum and maximum substeps. So we have global substeps also, and we have extra control over here as well. So you can use this minimum and maximum. So the solver will decide when to use minimum and when to use maximum. So for example, if you need high calculation in this frame, it will utilize this max. And if you have faster simulation and not that collision, so it will utilize this too. It will switch in between. Yeah, these three parameters you will mostly use. Second tab is update. Here we don't have to change anything, but just brief, I can just explain. So if you want to avoid calculating edge particles or use mask, or if you want to use this, so let me just show you. And you can see these particles are dying over here, and I don't want to calculate that. So it won't kill those particles. So those kind of stuff we have, but it will affect the attribute. So that is the dead attribute, which I will explain later. Cool. Next we have collision behavior. So let me just turn this on. Here we have option to define what it should do on collision. So at the moment it's colliding over here, so you can just add into some group, or you can add a color. So you can just create a collide group, so whatever is collided, and you can add different force on that thing, right? So these are the collided. You can add extra drag on that thing, and here you can set a response, what it should do. It can stop over there. Right, so you can check this, it stopped over there. And those are the slide, and other options are also there. And we have one more option is attributes. So here you can just add heat number, heat position, and this can be useful if you want to create laser simulation. You can just find heat frame, heat time, heat position, those kind of stuff we have. And next is slipping. Let me just disable this. So you have noticed over here particles are keep sliding over here, and if you want to make them static in some time, so you can just turn this on. And here we have velocity threshold. So if you increase this, particle speed goes below this velocity threshold, it will stop. That range is not working, so you can increase it. Let me just pin this over here, reset. Yeah, now it's working. Let me just use 3 only. Four. It means particle movement is more than 4, so that's why it's not stopping over here. Minimum is 5, so it will just stop there. See, so it's just stopping in there. And here we have slip delay also. You can see it's just stopped in the middle of the air, so you can just add 2, so it will gradually slow down. Cool, so you can just use slipping color also now. It's activated here. And to control this kind of stuff, we have other thing as well, so at the moment it's following constant speed, right? So if you use this increase friction dynamic range, and let me just reset everything over here, and now it won't slide that much. See, so let me just use this much only. Yeah, I have to reduce this even more. Yeah, see, now it's not sliding that much now, so you can just play around with this value, so it will stop. Yeah, see, now it's below 1. That's why it's stopping over there. So this is the threshold. Starter slip, whatever is emitted on first frame, meaning simulation frame, first simulation frame, it will be inactive. And at the moment we have continuous emission, right? So let me just emit on first frame only. So here I want to use impulse activation 0, and I want 1000. Yep. See, it's not moving now. And if I turn this on, it will move. If you have continuous emission, it won't work. Cool. So next is binding and distribution. It's useful for farm and stuff. Cool. That's all. That's just basics of particles. And this was just a brief of all these parameters. And don't worry if you didn't understand some parameters. So now we will create fireworks, and it's always easy to understand things with example. So let's create fireworks next. Let's create fireworks. I will delete everything. I don't want anything over here. So I'll just need sphere. So I'll use this as a source to emit particles. And let me just rename this particle sim. Yeah, this is my source. All we need is popnet. So I will get this node flow over here. And yep, it's emitting now. Cool. We have to set a velocity, right? So it will go in up direction, but at which speed? So let's just Google it. So if I search this, it's saying that firework speed is 45 meters per second, right? So we can use this. And here we need to just use, and can just set this over here, and we can use 45 over here. Yep, so this is the speed. So at the moment I'm able to follow real speed like 45 meters per second, right? But in production you will have camera, you will have sky level as well. In that case you have to set value according to your scene, and based on that you have to visually match the speed. So follow some reference in that case and check how fast it's moving. So accordingly you can just match the speed. So you can just set this 20 and keep your reference over here and just check it's matching the speed. No, just increase it 45 and 47, it's up to you, right? So this is not exact value you have to follow. You need to just set everything according to your scene. Whatever is there in the screen, it will sell. So you have to work accordingly. Yep, and I have lots of particles over here. I want reduce. Maybe let's use one only, because it doesn't emit that much. Here I can use anything over here. If I use this, it will continuously emit. See, I don't want that. I want one or two particle per second. Yep, this is best. Yeah, see, it's creating random gap also. Cool. Next one I need is trail. And how do I create a trail? Because these are single particles and there is always a trail, right? So let's create trails. For that I need pop replicate. And here if you check, it's all same. Whatever we have learned over here, it's similar only. So what is new? Shape and noise. I will briefly explain this tool in some time, but let's just connect this. Let's connect this over here and check. So is it emitting? Yes, it's emitting over here. But at the moment it's just following same speed. So we have to go to attribute and we can just reduce inherit velocity over here. So let's just reduce 0.1 and check. Yep, can you see? It's creating a trail. And that's too long trail, so I want to delete life also. Yep, that's fine. See. And what is the second input over here? Let's connect that over also. So it says it's a reference over here. And what is this reference? So it won't emit anything over here. So it will use this as a reference. So it won't simulate this separately. That's fine now. And here we already know how things works. Let's just check what is shape over here. And shape is nothing but it will just create some shape. If I use box and I can increase this. Let me reset over here. Yeah, you can see it's a box over here. Let me increase count so you can just clearly see this. Yep, it will follow box shape. So I don't want shape over here. But before that, let's just add noise. So you can see it looks too boxy, right? So if you want to add additional noise on that, you can do that also. See, it will add some noise on top of that. These two are useful to change shape of emitter, but you can just disable this and I want sphere and scale is 0. Yep, as you can see. And here I want to add some variance. We can see some, it will have this trail over here. And again it's creating stepping over here. So let's just straight away go and increase substeps to fix it. Yep, it will fix. But let's understand these things. Never use substep directly. Always find some alternate solution to fix this kind of stuff. So let's just understand why it's happening over here. So this is the main point we have and it's creating these particles. So why it's creating gap? All of them has same speed, right? So it's inheriting. So this has one, this has one, right? So what we need is we need some range in this thing. So if we have random, then it will fill this gap. So at the moment particle is moving in this direction. That's fine. And whatever is emitting also it's correct. It's totally correct because we are not simulating this in between frames, right? If you want to calculate that precise in between frames, in that case you have to use substeps. Then only it will just read this and fill this gap technically. But I don't want to take extra simulation time or something. That's why I'll just find a quick solution. So in that case, we can just use drag. So here is the reason. Here I want to apply drag on these particles only, not on these. So if I have used this over here, I had to apply on both of them, right? So it's fine now. I can just apply on emitted particles and I can just name them also trail. Yep. And by default, it's 1. So that's not so useful. What I need is random. So I'll just go over here. So this thing is very useful. Always use this. So whatever we have over here, and remember I have discussed about the ID. It has random value. So we will utilize that only. So you can just type over, go over here. It's air resist. So don't type air resistance. It's air resist. Air. Right. So I want to use this multiply and random at ID and I want to use from fit 0 to 1. So take a screenshot of this. This is the most useful wax and I will explain in some time what's happening, but let's see the result. So why there is no difference? Because we have reduced over here as well. So I want to use first this, and let's just play. Yep, it's fixing. Still it's not fixing over here, so I want to reduce this. 0.1. It's fixed. That's just nice and easy way to fix. And I can just spread this from here as well, so I can just increase this. Yep, but that looks too uniform, right? So I will just use pop force. And this is right time to explore pop force also. So here we have some parameters. This is force, in which direction you want to add this. So you can add some wind also on these things. It will look cool. See? Right. So I don't want winds. What I need is this swirl noise. And what is this swirl size, swirl scale, pulse length, and everything over here? We have that. This is amplitude over here, and I want to use amplitude 1. Let's see over here. No difference. Let's increase 10 times. Yep, now you can see. Yep, that's fine. So what is the swirl size? So swirl size basically a noise scale. So if I use box over here, and this is what it will apply. So at the moment swirl size is 1, so it will apply this noise. And same we have control in axis as well, and pulse length is basically speed. How fast noise flow you want over here. So how this is works is, if I reduce pulse length, it will increase noise speed. And if I increase pulse length, it will reduce noise speed. Let me just explain it quickly. And here it's not visible clearly, but let me use grid to show you. Yep, and let me increase this. Yeah, see, let's just stay on this frame and pin this. Let's increase particle count also. So these are the things that you will mostly use, and just understand these things clearly. Yep. And as you can see, it's traveled too much, right? So if you reduce this thing over here, it will travel less. Let me reset this. Let me just go one frame. Yep. So you can just clearly see the difference. And reference is the extra noise. It will just break the noise more with high frequency, and there are other options as well. But that's all for now. Let me just delete these. We understood this part, so I don't want to change anything. Just keep, and I will reduce this life over here. Yep, that's fine. And I want to talk about this wax now. So what's happening over here? So air resistance is 1. So if we use air resistance, it will slow down the particles. It will work as an atmospherical drag. We have wind that slow down things. That's what we can use this as a drag. It will start with the speed, and it will gradually slow down the speed overall using this drag. And here we have just wind velocity also. You can set in which direction it should move, and air resistance is a drag basically overall. And why I'm using this fax? So if I use air resistance, it will assign one value, one drag to all particles. So all particle will slow down at same time. That's not what I want. So here I will use some VAC. So random ID. So what is random ID over here? Let's just understand. So if I have multiple ID over here, meaning 5. So this is from 1 to 5 I have, right? So it will just use randomize it, and it will give me from 0 to 1. So we will have gradient between that 0 0.5, 0 0.6, 0 0.8. So it will randomly assign on all of these 5 particles. And I will just use this fit value over here. So as you can see that I have 0 also over here, right? So I don't want that 0. I want 0.1 instead, because if I use 0, then it will be too fast. It will apply 0 at resistance, and that's not what I want. And I have max, 1 is fine, but here you can just use 2 also. It will fit by 2. So that's what this wax is doing over here. And that's a quick way to fix this kind of stepping. And let's just add ramp color also. And I want ramp. So by default it set something over here. So let's just see. And I want reverse of this. Oops, it's not moving. Let me use this black. And we can just use yellow. That's fine. See. And this ramp is using something called NH. And what is this NH? But before that, let's just check. Do we have that attribute? Let me search for NH. So we don't have that attribute. So NH is a hidden attribute over here. And let's just talk about it. And this is right time to explore geometry spreadsheet also. So let's go to geometry spreadsheet over here. And we have multiple things happening over here. So you just need to focus on this point because we are working on point. Just select this node and click these points. And here we have lots and lots of attribute over here. So not all of them are useful, right? So we can just filter them out one by one. So this is position. So it's point position. And here we have age and how age is working. So if you see in the start frame, it's 0 and it increasing. And next is air resistance that we have already talked about, right? So you can see that we have range over here. Let me just pin this and let me disable that pop drag. So now we don't have air resistance over here. So that's what creating that thing. And we can disable this wax also. Now we have all of them, one only. So that's how it works. Yeah. Now let's understand what is NH. So how NH calculates, it uses this age and life over here. So let me just filter them, age and life. So I'll just focus on age and life only. So 100 is those 2 particles, life of this thing. And that also we will talk about when it should burst in next video. So it will divide this age by life. So this age moves from 0 to 0.5 because we have this life. So you won't see particles above 0.5. It won't cross that value. Here it's crossing because we have this life is 100. So that's fine. To explain you this quickly, let me just use some wax. And I want to grid over here. Just this is for explanation that what is happening in the backend. I'll just use point triangle. So I have this age. I want to create a parameter. And I have this life, which is 0.5. And I want to calculate NH, age divided by life. Let me unpin this. Sorry, I have to mention this at. So interesting part is it won't show this NH over here because that's hidden attributes. So here you have to change this to capital N to visualize this. And it's not only that, you can use XYZ also, just different from NH. And let's just check. Let me create this. And this is my particles. It's aging, 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 aging. So if I stop at 0.5, it's 1. So NH is basically the value from 0 to 1. And you need to clearly understand that how things work, because that's most useful, and based on that only we will just add some color variation and everything. right? So you need to understand this mathematics, little mathematics behind it. And in this example, it will cross, but in particles, it won't cross because we have set age limit there. 0.5, it will stop and delete the particle. Cool, that's understood. Let's delete this. Clear and know how to use this geometry spreadsheet also. And if I select this, it will show lots of confusing stuff that you have to go inside. Just create a null and just it will be easier for you to explore things over here. Yep, you can track everything over here. ID, particle, hit points, everything. Cool. Let me press L to organize things. So next we will talk about burst and how to set burst timing and everything.